Hello, I'm Idan Kentor from Dell Technologies. In this demo, I'll be showcasing SUSE Virtualization VM protection using Dell PowerProtect Data Manager. PowerProtect Data Manager with version 1921 features protection of SUSE Virtualization VMs, formerly known as Harvester, in addition to the proven container data protection that we've had for quite some time. PowerProtect Data Manager supports SUSE Virtualization and features support for block and file system volume modes. PowerProtect Data Manager features the ability to restore on a per VM basis, along with orchestration capabilities such as protection of VM spec, data, including data volumes from PVCs, MAC address provisioning, and the option to restore to the original or an alternate namespace, including powering on the recovered VM. Now let's head over to the SUSE Virtualization console to have a look at our production VM. This is our production Windows VM on the namespace with the same name. Let's have a look at the VM configuration. As you can see, the VM has a block access mode disk provided by Dell PowerStore, using a storage class called PowerStore Block. Let's open the console to Windows VM and check out our SQL Server database, connect to the instance, and look at the data on our customers table in the demo database. With that, let's protect this VM by bringing up the PowerProtect Data Manager UI. First, let's look at the registered asset sources. We have our SUSE Virtualization cluster registered as an asset source. As you can see, all of the namespaces discovered as assets. By filtering the protected assets, we can see that I already have a couple of protected namespaces. It's worth mentioning that if you are already using PowerProtect Data Manager, or PPDM for short, to protect your container-based workloads, you don't need to register anything new to protect your KubeVirt-based VMs. Now let's go to the protection policies and add a policy in order to protect our Windows VM. We'll call it Windows 2022 prod and find the namespace out of a list of discovered Kubernetes namespaces. Let's configure a primary backup stage, pick our data domain protection storage, configure a schedule of an hourly backup with retention of 30 days, and off we go. Here's the protection policy we just created. Let's perform an ad hoc backup of the namespace. We'll monitor the progress of the backup process. I'll fast forward through this part, but note the steps. PPDM first performs some metadata backup, issues a CSI snapshot of the PVCs, and then backs up the snapshot of the PVCs and data volumes. While the backup is running, let's switch to the CLI. Let's have a look at the running pods on the PowerProtect namespace. We have our lightweight controller pod and the data mover pod, also known as cproxy, which is spun up for the duration of the backup. We can also see our Windows VM. We'll switch back to the Data Manager UI. As final steps of the backup job, PPDM automatically deletes the CSI snapshots and creates the copy in the system. Through the CLI, you can see the data mover pod was automatically terminated once backup is complete. Let's switch back to our production Windows VM. We're witnessing human error in real time as the production database was accidentally dropped. No worries, PowerProtect Data Manager to the rescue. Let's navigate to the Data Manager UI and restore our VM to the original namespace. We'll go to the Restore section and locate our production namespace asset under the Kubernetes asset type. We'll pick the latest copy. The full list of copies can be seen by clicking on Change Copy. PPDM enables restore to original or alternate clusters. In this case, we want the application to be recovered as fast as possible on the original cluster. PPDM features the ability to restore on a per VM basis, so we will choose the option of restoring Kubernetes virtual machines. PPDM also offers restore back to the original namespace or a different namespace existing or new. We will go with the option of restoring to the original namespace. In this step, we can select which VMs to restore, so we will pick a Windows VM and include all of its disks. As mentioned earlier, we can also power on the recovered VM, and by default, the VM configuration will be restored. Finally, execute the restore. Great, the restore process was initiated. Let's monitor its progress. Awesome, the restore is now complete. Let's shift gears and open the SUSE Virtualization console to see that our Windows VM is up and running. Next, we'll copy its IP and connect to it via remote desktop. And we're in the VM. We'll connect to the production SQL Server instance, locate our database, and finally query the customers table. As you can see, the data is there. We're all set. There you have it. Thanks for watching and see you in the next demos.